All right, so we're going to do some examples. All right, so let's take the integral of x to the fourth power. All right, with respect to x, well, let's say this becomes x to the fourth plus 1 over 4 plus 1 plus c, which is equal to x to the fifth power over 5 plus c. All right, so this is your antiderivative. All right, let's see, let's verify really quick. All right, what is the derivative of this? Well, let's see, there's a 1 here in front, so it's actually 1/5. Hold the 1/5, right, as a constant. The derivative of x to the fifth is 5x to the fourth, plus the derivative of your constant is 0. This 5 and this 5 is gone, they divide out, and x to the fourth. Ta-da! All right, so what happens now if I tell you the integral of x to the -3? All right, with respect to x. All right, it is still a power function, it has a power. All right, so let's see, let's apply the formula. X to the -3 plus 1 over -3 plus 1 plus c. All right, -3 plus 1 is -2, so this is x to the -2 over -2 plus c, which is equal to -1/2 x to the -2 plus c. If you want to simplify all the way, this is actually -1 over 2x squared plus c. All right, negative exponents comes down. All right, so it works. It works. You can try to take the derivative of this one, and you should be able to only get x to the -3 power. Okay, but this problem, it was meant to show you that we need to be careful in this formula. All right, because remember, this formula works really nice for power functions. All right, but it does have a division. All right, you need to be careful on your division, because remember, we cannot divide by 0. All right, so if we are always adding, I should use the highlighter. If we are always adding 1, all right, so what number is not this x allowed to be? -1, right? So then that means that this is not allowed to be a -1, all right, which means that the integral of x to the -1 dx, this formula doesn't work. All right, and what is x to the -1? This is the integral of 1 over x dx. All right, this integral, it's really nice. All right, but it does not follow this formula. All right, but any other power function does. All right, so you need to modify this one. All right, and to -1. All right, ta-da. Alrighty, and then we still have the integration of some basic trigonometric functions. All right, so I'm gonna only give you these 3. All right, so let's see. If we know that the derivative with respect to x of sine of x is equal to cosine, let's see, sine of x plus c, and it makes sense here. What is the derivative of sine of x? Well, cosine of x. All right, where does cosine of x come from? From sine of x plus c. All right, so let's see, if we know that the derivative of cosine of x is negative sine of x, all right, what is the derivative? This negative is just a constant, so you're always going to be able to hold it. So the most important thing to know here, the derivative of tangent of x is equal to secant squared x. All right, what is the antiderivative of secant squared x dx? Bad notation. Taking the integrals of these two functions. All right, so this one, a square root of x, can be rewritten as the integral of x to the 1/2 dx. It is a power function, so we should be able to use a power function for antiderivatives. All right, so this is equal to x to the 1/2 plus 1, and this one is going to be 2 over 2, all right, over 1/2 plus 2 over 2, all right, plus ta-da, c. All right, this is 3/2, so it's equal to x to the 3/2, all right, divided by 3/2. All right, so this is kind of like a fraction over a fraction. All right, so or this is equivalent to 2/3 x to the 3 halves plus c plus c. Do not lose that c. All right, this one, all right, so this one is a constant. We can actually hold it out. All right, so it's 2 times the integral of sine of x dx. So the question is, what do I need to take the derivative of to get sine of x? So let's say the derivative of sine is cosine. The derivative of cosine is negative sine. So it must be that the derivative of negative cosine must be sine. All right. So this is equal to negative 2 cosine of x plus c. Before we start integrating polynomials, I want to make sure that we remember that when we take the derivative of x, that is equal to 1, right? Why? Because there's a 1 right here. All right, so for integrating polynomials, all right, what is the integral of this? All right, well, that's actually saying what is the integral of 1 dx. All right, so where did 1 come from? Well, what did I have to take the derivative of to get a 1? Well, 1x. All right, so that is just x plus c. All right, so let's see another one. What is the integral of x plus 2 dx? This is example 1. This is example 2. All right, what is the integral of x plus 2 with respect to x? Well, this is a sum. All right, we can actually split it. This is the integral of x with respect to x plus the integral of 2 with respect to x. All right, the integral of x is, well, remember this is x to the first power. We need to go up a power, x to the second over 2 plus c1 plus, all right, what is the integral of 2? Well, 2 came from 2x plus c2, right? Another constant. All right, so here we can rearrange, all right, and this is actually equal to x to the second power over 2 plus 2x plus c1 plus c2. All right, this c1 plus c2 is just going to be another constant. All right, let's call it c3, but then at this point we just start naming every single c value. So let's just say that the result of adding all these constants together is just going to be a constant c. All right, algebraically, so this is equal to x squared over 2 plus 2x plus a constant c. All right, can we verify really quick? Well, the derivative of this would be 2x. The 2 and the 2 will divide out, so I'm left only with x, plus the derivative of 2x would be 2, right? Good. Plus the derivative of any constant would be 0. Bingo. Loteria. Ha ha ha. Uno.